Okay, section 11.3 is our geometric sequences and series. So for our vocabulary, we have our geometric sequences, and that is when there is a common ratio between the terms. All right, and then the common ratio, that is going to be represented by the variable r, and that's the value that is multiplied to get the next term. When you are looking for that ratio, if you don't know what it is, because sometimes it is a fraction or a decimal value, you are going to take one of your terms, so let's say it's a sub n plus 1 over a sub n. So you're going to take a term, a sub n, that would be on the bottom, and then the next term, and you would divide those, and that would give you your r value. Then we have our geometric series, and again, series, that's when you are finding the sum of the terms. And there's going to be finite and infinite series sums that we're going to go over, but that'll be the last part of the video. All right. Okay, so now that we know all of the different types of sequences now, we're going to decide whether the sequences are geometric, so they have a common ratio, arithmetic, common difference, or neither. If they're geometric, identify the common ratio. So if they're geometric, we need to know our r value. And then if they're arithmetic, you need to make sure you find the common difference. And then if there's a neither one, we're not going to put anything else because we are just identifying the ratio and difference for those two types. All right. So if I look at this first sequence, I can see I would need to add 4 to get the next term or multiply by 3. If I were to add, I would add 12, so I know it's not arithmetic because of that. But if I continue to multiply by 3, I would get 18, and then 54, and then 162. With these sequences, you want to make sure you check for all of the terms that are given because sometimes the first couple will be the same ratio or the same common difference, and then the last one will be different. So make sure you're checking all of them before you definitively say, yes, it's geometric or yes, it's arithmetic. So this one's geometric, and they want the common ratio, which is 3. All right. Looking at our next one, if I'm adding, I would add 6, and I'm just going to keep adding because I can't multiply 5 by a whole number, so I'm going to just double check that I can just add. Because 5, I would have to multiply by some sort of decimal to get 11, so this one isn't geometric, but it is arithmetic. And they want the common difference, which is 6. Then if we look at C, this one, the first one, we would add 1, then we would add 3, and we would add 4. So this one's not arithmetic, and I would have to multiply that by 4/3 to get that, and then 4 times, that would be 7 over 4. So this one's not arithmetic or geometric, so this one would be a neither. And when it's neither, there's nothing else we have to identify about that sequence. Okay, you should try the next 3 on your own and then hit play to see if you got them correct. For this one, we would start by multiplying by 1 and then multiplying by 2, so not geometric, and then we would add 0 and then add 1. That means not arithmetic, so this one's also a neither sequence. Then if we look at E, this one looks like we're subtracting 5. And if I keep looking, that pattern does continue. So that one is arithmetic with a common difference of -5. Okay, and then the next one. All right, so this one it is not being multiplied by a whole number because they are getting smaller. So the way you could figure out what it's being multiplied by is by putting 27 over 81. So you want a number over its previous term to find your ratio, and this would equal 1 over 3. So I'm basically dividing by 3. So when you multiply by 1/3, that's the same as dividing by 3. And if I look, that pattern does continue till the end, so that makes this one a geometric sequence with a common ratio of 1/3. All right, those are our 6 examples for those. Next, we're going to go over the rule for our geometric sequences. For those, we have a sub 1, which again is our first term, multiplied by r, which is our common ratio, raised to the power of n minus 1, where n is still the term number. That will also be given to you on your formula sheet. You will need to know when to use it and how to use it though. All right, so for example number 2, we're going to consider the geometric sequence 81, 108, 144, 192, 256. They want us to write an explicit and recursive rule for the nth term. That was hard. Okay, so this rule they give you, that is the explicit. That will be on your formula sheet. The recursive rule will not be on your formula sheet. That one you have to memorize how to do. So for my explicit rule, I'm going to start it. I know it's going to start with a sub n equals, and then a sub 1 is my first term. And if I look, my first term is 81. And then I'm going to multiply it by r, and that's raised to the power of n minus 1. So I just need to figure out what my r value is. So to find r, you are going to take two terms that are next to each other, and you are going to set them up as a fraction. And you want the second term over the previous term. So I'm going to take 108 over 81. And then I'm going to grab my calculator. Oh no, where'd it go? There it is. Okay. So I'm going to grab my calculator. Okay, it works when I don't want it to. There we go. Okay. Oh, that's not going to show me anything. Okay, let's exit out of all these ads. Sorry about this. Okay, so we had 108 over 81. So that gives me a decimal that repeats and does not end. When we write our rules, we want them to be exact numbers. So we want it to be a fraction. To do that, you're going to hit math and then hit enter twice. So that gives us the fraction 4 over 3. So my r value equals 4 over 3. So I can plug that into my equation, and now I'm done with my explicit rule. Then I can write my recursive rule. Remember, that has two parts. So a sub 1, which equals 81, and then a sub n, which starts with a sub n minus 1. And then we multiply by what is being multiplied by each term to get to the next one, which is our r value, 4 over 3. And those are our two rules. Next, they want us to find a sub 11. So I'm going to plug it into my explicit rule because that one is going to be the fastest way to find the 11th term. And this is what you can type into your calculator. When you type it in, make sure the 11 minus 1 is all in the exponent, or simplify it to the 10. So I'm going to type in 81 parenthesis, and you can use the fraction button, or you can do 4 divided by 3. Both will get you to the same answer for the problem. And then to the power of 11 minus 1. So when you get an answer like this will happen a lot, especially if we have a 3 in the denominator. You can round it to 1 decimal point. So we're going to have 1,438.4. And that's our answer. Okay, so you should go ahead, pause the video, and try example 3, and then we can go over the answer. Okay, So for example 3, they want you to write an explicit and recursive rule for the nth term. So it is geometric. They told us that in the directions. So we are going to set it up in our rule. So we know a sub n equals our first term of 5 times our common ratio to the n minus 1. So to find my common ratio, I'm going to take two terms that are next to each other. I'm going to put the second one on top and then the first one on the bottom. And then I can find my common ratio. And in this example, that is going to be 2. So that's my explicit rule. Then I'm going to write my recursive. For that, there's two parts. So a sub 1 equals 5. And then I write a sub n equals a sub n minus 1. And then we multiply by what's happening to get to the next term, which in this case is times 2. And when we find a sub 25, we're going to plug it into our explicit rule. So we'll have 5 times 2 to the power of 25 minus 1. Now that exponent's pretty big, so our answer is also going to be pretty big. And when you type it in, you should get 83,886,080 for your answer. So make sure you are practicing typing these into your calculator so that you are getting the correct answers when you are on the test.